Hello, welcome back to our channel Adamya Education. We are conducting the third live session for this chapter, Trigonometrical Identities, and today also I have come with a variety of questions and I hope it will be beneficial for you. So let's begin with our first question. So we have to prove that cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A is equal to sin A plus cos A. So let's begin. With LHS. Cos A by 1 minus tan A plus sin A divided by 1 minus cot A. So as we see that in the right hand side we have the values in terms of sin and cos. So we are going to convert this tan and cot into sin and cos. So cos A divided by, in place of tan I can write sin A by cos A, and in place of cot A I can write cos A by sin A. So now we have fractional values in the denominator. So I'm going to simply take the LCM like we have been doing in the past few lectures. So let's do it. So we will have cos A divided by cos A minus sin A divided by cos A plus sin A divided by sin A minus cos A divided by sin A. So this cos will get multiplied with the cos over here, and this sin will also get multiplied with the sin out here. So let's do it. So we are left with cos square A divided by cos A minus sin A Sorry for the inconvenience, my friends. I just had to pick up a call. So let's continue with our question. And out here we have sin square A by sin A minus cos A. I hope you can understand my handwriting. It is becoming very difficult. I don't know why to write on the screen today. Now as we see in the denominator, we have cos A minus sin A here. But out here we have sin A minus cos A. We have done a similar question previously. In order to convert this, in order to make it equal, we can just do one thing. We can take minus common from this expression, and hence that minus will replace this plus sign, isn't it? We have done it yesterday. So let's write it in that manner. So cos square A divided by cos A minus sin A minus sin square A divided by cos A minus sin A. So now both the denominators are same, so we can write it under a single fraction bar. So I don't have space here, so I'm continuing it in the next page. So my denominator is cos A minus sin A and in the numerator I have cos square A minus sin square A. Cos square A minus sin square A. Alright. So in the numerator we see that it is of the form a square minus b square. So we can write it as a plus b into a minus b, that is cos a minus sin a into cos b minus sin b divided by cos a minus sin a. So this is getting cancelled. So we are left with, okay, over here we'll have plus cos. I don't know what I am doing. I have written b out here. I'm very sorry for the inconvenience. It will be b out here. It will not be b out here. It will be a. Okay. So let's do it once again. Cos a plus sin a into cos a minus sin a plus b into a minus b, and over here we have cos a minus sin a. So this will get cancelled out and we are left with cos a plus sin a. And I guess this is what was asked. Yes, this is the right hand side. So equals to RHS proved. So it was as simple as that. You just have to see what was there in the RHS and accordingly you have to change your question. You have to modify the question on the left hand side. Alright, just copy it down so that I can erase it and then we can start with the next question. Alright, the first step, see what do we have out here? We have cos a by 1 minus tan a and we have sin a by 1 minus cot a. In the right hand side, we have sin a and cos a. We have the values in terms of sin and cos. So in order to bring that, we are converting tan and cot into sin by cos and cos by sin respectively. Whenever we start with such proving questions, we have to see what we have to prove. If we have to prove something related to sin, then we will convert everything into the form of sin. If we have to find out the value in term of cos, then we are going to convert everything in terms of cos. Similarly, out here we have the RHS in terms of sin and cos. So we are converting both tan and cot in terms of sin and cos. This is the reason. So in place of tan a, I have written sin a by cos a, and in place of cot a, I have written cos a by sin a. I hope it is clear now. So let me erase it and let's begin with the next question. Alright, this is an easy one. We have to prove that 1 minus tan a divided by 1 minus cot a whole square is equal to tan square a. So over here we see that in the left hand side we have in terms of tan and cot, but in the right hand side we have in terms of tan. We cannot make any changes from here directly. So we have to convert it into sin and cos form. Okay, I'm happy that it is clear to you. So let's begin with the LHS part. So we have 1 minus tan a divided by 1 minus cot a whole square. So in place of tan a, I will again write sin a by cos a, and in place of cot a, I will write cos a by sin a. So 1 minus sin a by cos a divided by 1 minus cos a by sin a whole square. So in both the numerator and the denominator we have fractional values, so we are going to find the LCM. So in the numerator we have the LCM as cos a, and here we have cos a minus sin a, and in the denominator also we have to find the LCM. The LCM is sin a, and here we can write sin a minus cos a whole square. So as you can see that in the numerator we have cos a minus sin a, but in the denominator part we have sin a minus cos a. The same thing again. In order to make it same, there will be a negative sign which will be taken as common. So let me write it in that manner. I can write it as cos a minus sin a divided by cos a, and if I take a negative sign as common from the value out here, I will get cos a minus sin a divided by sin a. So this negative sign is coming from the fact that I am converting this value in the form of this. That's why I have taken this negative sign outside, just like the previous question which we did. So whole square. Now what do we see? This value and this value is getting cancelled out. We are left with minus 1 by cos A divided by 1 by sin A whole square. You could have directly done it. I'm just trying to make it a little more simpler. So now we can write it as sin A by cos A. Simple division formula for fractions whole square. So we know sin A by cos A is tan A. So minus tan A whole square, which is equal to tan squared A. So this is what was asked, isn't it? Yes. So this is equal to RHS, proved. So please copy it down. I hope it is clear. If you have any doubts, you can please mention it in the comment section. Right, let's do this question now. Okay, so we have sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So let's begin. So starting with LHS, we have sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. So we see that in the numerator we can take sine theta as common, and in the denominator we can take cos theta as common. So let's do that. So sine theta is taken as common. So we are left with 1 minus 2 sine square theta. And in the denominator we can take cos as common, cos theta. So we are left with 2 cos square theta minus 1. Okay. So we have got this tan theta, isn't it? We have this sine theta by cos theta. So basically we have got this tan theta. We have to eliminate this part, the second part. So let's see how we can do this. So I'll keep everything as it is. Let me do one thing. I can take this sine square theta as 1 minus cos square theta. So I can write it like this, 2 bracket 1 minus cos square theta. Simply I am using the square relation in order to write sine square theta as 1 minus cos square theta. And I'm going to keep the denominator as it is. Let us see if it yields us the RHS. 2 cos square theta minus 1. Alright. So let me write this directly as tan theta, and then let me solve the second part. Okay. Now what do we have? 1 minus 2 plus 2 cos square theta. I'm just simply removing the bracket and I am solving it out. And in the denominator I have 2 cos square theta minus 1. Okay. So now let us solve the numerator. I hope it will get cancelled out. It seems so. So we have 2 cos square theta. Okay, it was theta. I wrote A out here. Theta. 2 cos square theta minus 1. 1 minus 2. So minus 1. And 2 cos square theta is remaining as it is. Divided by 2 cos square theta minus 1. So yes, they are getting cancelled out. And we are left with tan theta, which was asked in the question. So let me write it. Equals to tan theta is equal to RHS. So I hope it is clear. It was a very simple question, although it looked a little complicated, but it was very easy. Let's move on to the next question now. We have to prove that 1 plus cos theta minus cosec theta into 1 plus tan theta plus sec theta is equal to 2. So I guess this is going to be very easy. I guess you also have understood from whatever we have done yesterday, that we have to simply convert this cot thing, cosec thing, and tan and sec thing into the normal values we know in terms of sine and cos, and then we will get the answer easily. So let's give it a try. Let's try to see if we are moving correctly. So LHS 1 plus cot theta minus cosec theta into 1 plus tan theta plus sec theta. Okay, so let us convert cot into cos by sine and cosec into 1 by sine. Similarly, tan into sine by cos and sec into 1 by cos. 1 plus cos theta by sine theta minus 1 by sine theta into 1 plus sine theta by cos theta plus 1 by 1 by cos theta. Okay, so we can take the LCM. Will it help in any way? Okay, let's see. So if we take sine theta, it is the LCM. So we will have sine theta plus cos theta minus 1, okay, into the LCM out here is cos theta, and we have cos theta plus sine theta plus 1, okay. So we can write it like this now under the same fraction bar: sine theta plus cos theta minus 1 into sine theta plus cos theta plus 1. Okay, so I don't know if you can see it or not, but I can see a plus b into a minus b thing. So we can use the identity which we have learned. So in the denominator we have sine theta cos theta. I don't know why my screen is so greasy today. It is so difficult to write. Okay, so I'm using a different color. I hope you'll understand this thing now. You can see that we have a difference in sign between sine theta cos theta and 1. So this is 1 unit in both the cases, and 1 is the other unit. So if I take sine theta plus cos theta as A and 1 as B, I have A plus B into A minus B. That means I will be left with sine theta plus cos theta whole square minus 1 square. I hope this is clear. It is of the form A plus B into A minus B, so I can write it in the form of A square minus B square. So sine theta plus cos theta whole square minus 1 divided by sine theta cos theta. Okay. So now we have A plus B whole square. So let us solve it out and let's get the answer. Sine theta plus cos theta whole square, that is sine square theta plus cos square theta plus 2 sine theta cos theta, and we have minus 1 also, and in the denominator we have sine theta cos theta. Okay, so sine square theta plus cos square theta is 1 from the square relation which I taught you in the first day of this session, into 2 sine theta cos theta minus 1 divided by sine theta cos theta. So 1 and 1 is getting cancelled out. So we are left with 2 sine theta cos theta divided by sine theta cos theta. So it will get cancelled out and we can have 2. And this is the RHS, yes. So we have very easily proven it. So like I told you yesterday, I'm repeating it once again. You have to be very clear about the identities which you have learnt in the lower classes. So that, okay, second step, alright. So what we have done out here, just see. First of all, we have converted cot into cos by sine, cosec into 1 by sine, tan into sine by cos, and sec into 1 by cos. Alright. Now what we have done, this entire thing is under one bracket, so we can take LCM and we can write it under the same fraction bar. So sine theta was the LCM, so we have written the numerator now as sine theta plus cos theta minus 1. Similarly now, the second part, this one, we have a multiplication sign in between, don't get confused. These both are getting multiplied with one another. So now for the second term inside the bracket, we have the LCM as cos theta. So our numerator in that case becomes cos theta plus sine theta plus 1. And hence now I have taken it under the same fraction bar. I hope it is clear now. If you need doubt, please reply it down here. So like I was saying, your knowledge about the identities have to be very nice. Only then you will be able to quickly understand which identity you have to use where. So in case that you don't remember the identities or you have forgotten about them, please go through your class 8 or class 9 books where you have all those identities given one after another, and just write and practice so that it goes into your head. All right. Chinmay is saying once again, all right, let me explain that once again. So, okay, I'm explaining it once again. Have some patience. Please don't spam. All right, so, all right, so we have 1 plus cot theta minus cosec theta into 1 plus tan theta plus sec theta is equal to 2. In the right hand side, we see that there is nothing related to sine cos, no trigonometrical identities. That means it is very clear that all of them will just get cancelled out. So what we are doing, we are converting cot into cos by sine, we are converting cosec into 1 by sine, we are converting tan into sine by cos, and we are converting sec into 1 by cos. And then we are simply doing basic algebra, and then we are getting the value as such. For those who haven't understood it, after the live gets over, go through the video once again. I hope that will clear your doubts to an extent. Alright, let's do the next question. This is a different question. We are not proving something here. We are basically removing the theta out here. This is a very good question. Let's do. Okay. So we have to eliminate theta. In the answer which we will get, there will be no theta. So how do we do this? We have x is equal to k plus a cos theta and y is equal to k plus b sine theta. So we have to remove theta. Let's see how do we do it. Whenever such questions come, when you have to remove the value theta or you have to remove the angle like a, b, c, whatever, always remember that you have to use the identities, the square relation specially, because from there only we can get a value equal to 1, and as a result the theta part gets removed. So let's see, we have x is equal to k plus a cos theta. Let me find what is the expression for cos theta. So x is equal to k plus a cos theta. So x minus k is equal to a cos theta. You can skip this step, you can directly do it like the third step. So x minus k by a is cos theta. You could have directly done it from here. But for students who find it a little difficult to understand, for them the second step is given. Alright. So the value of cos theta is x minus k by a. Okay. Similarly, let me find out the value or the expression for sine theta. I have y equals to k plus b sine theta. So y minus k by b is equal to sine theta. So this is equation 1 and this is equation 2. We know one thing, that sine square theta plus cos square theta is 1. So if I square equation 1, what do we get? Whenever squaring or division or addition is done, I told you yesterday that if you multiply something with the numerator, you have to multiply the same value with the denominator also, and vice versa. Similarly, it applies to equations also. If you are squaring one side of an equation, the other side of the equation will also get squared. Similarly, if you are cubing or if you are finding the square root of one side of the equation, the same value or the same operation will be applied to the other side. You have to remember this. You are not just doing anything for one of the sides. You have to do it for both the sides. So if I square equation 1, what will I get? I'll get x minus k by a whole square is equal to cos square theta. Both the sides are getting squared. You have to write squaring equation 1 and 2. I'm not writing here. It's difficult to write because of this greasy screen today. So whenever you are doing it, write it in your copy. Squaring equations 1 and 2. Similarly, when we square equation 2, we are getting y minus k by b whole square is equal to sine square theta. So now we have the square relation right in front of our eyes. Now if we add these two equations, left hand side will get added with the left hand side and right hand side will get added with the right hand side. This is also another very important thing which you have studied in class 9 in simultaneous linear equations, but I am just telling you for recapitulation once again. So now I am going to add these two equations and I will get x minus k by a whole square plus y minus k by b whole square is equal to sine square theta plus cos square theta, and this is equal to 1. So my final answer is x minus k by a whole square plus y minus k by b whole square is equal to 1. So as you can see in the final answer, there is no sign of theta anywhere. So we have successfully eliminated theta. So this is how you have to do. I hope it is clear till here. Even in place of sine and cos, if we had cosec and cot, we had to do the same operation because cosec square theta minus cot square theta is 1. The same thing would have applied for sec and tan also. So I guess this is clear. Let's take a break of 2 minutes, drink some water, get refreshed, and then we will do some more questions, and then we are going to learn a few more things, although it is already known to you. But since we will require it in our next session, that's why I'll just do a quick revision of the previous topics. So welcome back friends. We have two more questions to be done and then we are going to do a quick recapitulation of the standard values of trigonometrical ratios. So let's begin once again. Okay. So over here also we have to eliminate theta as you can see, but we are not just going to eliminate theta, we are going to prove one relation also. So we have sine theta plus cos theta is given as m and sec theta plus cosec theta is given as n. We have to prove that n into m square minus 1 is equal to 2m. So let's see how do we do it. So let us write what we have first. Sine theta plus cos theta is equal to m. So if I square both sides, why I am squaring? Because we have m square in our relation which has been asked. That's why I'll square both sides. So if I square it, I will get sine theta plus cos theta whole square is equal to m square. So if I solve it, sine square theta plus cos square theta plus 2 sine theta cos theta a plus b whole square. So a square plus b square plus 2ab is equal to m square. So sine square theta plus cos square theta is 1. So I have 1 plus 2 sine theta cos theta is equal to m square. So now if I take this 1 to the other side, why I am taking 1 to the other side? Because see, we have m square minus 1. So if I take 1 to the other side, it will become m square minus 1. This is the reason I am doing it. So m square minus 1 will be equal to 2 sine theta cos theta. Alright. So we have got one part of this equation, that is m square minus 1. We have got its value. So let us keep it as equation 1. Similarly, we are going to find out the value of n. We are going to get an expression for n. Let's see. We have sec theta plus cosec theta is equal to n. So if I convert sec into 1 by 1 by cos and cosec into 1 by sine, I will get cos theta into sine theta as the LCM in the denominator, and in the numerator I will have sine theta plus cos theta. So this is equal to, this is not 2, this is n. Okay. So this is my expression for n, sine theta plus cos theta divided by cos theta into sine theta. This is n. And what is sine theta plus cos theta? See in the question, sine theta plus cos theta was m. So now I can write it in this manner. N is equal to m into cos theta sine theta. Isn't it? Now let's see what we can do. This is our equation 2. So our equation 1 is m square minus 1 is equal to 2 sine theta cos theta, and n is equal to m by cos theta sine theta. So we have to basically multiply n into m square minus 1. So if we multiply equation 1 and 2, we are getting the left hand side directly. So let's write multiplying equation 1 and 2. Whatever operation you are doing, whether multiplying, dividing, squaring, whatever, you have to write it down. So multiplying 1 and 2. So in the left hand side we have n into m square minus 1, and in the right hand side we have 2 sine theta cos theta into m by cos theta sine theta. M by cos theta sine theta. Alright. So we can cancel this cos theta sine theta. So we are left with n into m square minus 1 is equal to 2m. So this is what they asked in the right hand side. Yes. So this is how you can solve it. So like I told you, you have to use the identities which you have learned, the square identity especially, whenever you want to eliminate theta from the expression. So I hope this question is clear. This was a very interesting question. Okay, let's do the next question now. So So we have to prove that 1 minus cos A by 1 plus cos A is equal to cot A minus cosec A whole square. So we are going to start with the right hand side in this case, because we see that in the right hand side we have cot, we have cosec, we have square, we have so many things going on. So we are going to start with the right hand side in this case. So RHS cot A minus cosec A whole square. So cot A can be written as cos by sine. So cos A by sine A minus cosec A can be written as 1 by sine A whole square. So the LCM is not LCM, the denominator rather. We don't even have to find the LCM here. So the denominator is sine A, and in the numerator we have cos A minus 1 whole square. Okay. So cos A minus 1 whole square divided by sine square A. I'm squaring both the numerator and the denominator separately. So in the numerator we have cos A minus 1 whole square divided by sine square A can be written as 1 minus cos square A, isn't it? Yes. Now we see that in the denominator we have 1 minus cos square A, that can be written as 1 plus cos A into 1 minus cos A, but in the numerator we have cos A minus 1. So how do we change this sign to make it similar? Let us see. So if I take minus as common from the numerator, I will be left with 1 minus cos A, and the entire thing will be squared. And in the denominator I can now directly write it as 1 plus cos A into 1 minus cos A square minus b square, so a plus b into a minus b. Now this negative sign, when it is squared, negative into negative becomes positive, so we will just be left with 1 minus cos A whole square, and in the denominator we have 1 plus cos A into 1 minus cos A. So now these two terms get cancelled out, and hence we have 1 minus cos A divided by 1 plus cos A, and this is the RHS. So we have proved. Sorry, this is the LHS. We have been writing is equal to RHS for so long that I completely forgot that we started with RHS this time. So this is equal to LHS proved. So I hope whatever questions we have done till now, it is clear. If you still have doubts regarding any question, or if you have maybe any other question from your book or from somewhere you have seen, any website, anything, just please feel free to mail your doubts in the mail given in the description. And next we are going to start with a new thing, but not today. We will do it in the next in the next live session. But before that, we will do a quick recapitulation of the standard trigonometrical values for angles like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree for sine, cos and tan, because these are the most important ones, and if you just inverse them you can get the values for cosec, sec and cot. And in the next chapter, which we will learn, that is heights and distances, we will extensively use the values of sine, cos and tan, especially tan. So you have to be very thorough with the standard values of tangents, all the tan thetas for 0, 30, 45 degree, 60 degree and 90 degree. You should be very well equipped with that. So let us do a quick recap of the same. So I would urge you all to make this table along with me in your copy, so that even if you have forgotten some values, you will quickly be able to remember it. So we have, first of all, we have sine, then cos, and then tan theta. 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Alright, so sine 0 degree is 0, sine 30 degree is half, sine 45 degree is 1 by root 2, sine 60 degree is root 3 by 2, and sine 90 degree is 1. And if you know the values of sine, you can simply inverse it. Like we are going to start from the back now, and we are going to find out the value of cos theta. So cos 0 degree will be 1, then it will be root 3 by 2. For 45 it will be 1 by root 2. For 60 degree it will be half, and for 90 degree it will be 0. We are just moving from right to left, as you can see. But we have to remember these values also. We just cannot do this trick and keep on making the tables in our answer sheet. It will not just kill a lot of time, but it will also make you feel that we can very easily use this trick and solve the questions. But no, you should try to remember it. So the best way for that is you have to practice. You have to keep on practicing. That's the only method you can apply. Next, for tan, we have to simply divide sine by cos, or the best way again would be to remember these things. I would never tell you to memorize, rather practice and etch it in your memory. So for tan theta, the value of 0 degree is 0. For 30 degree, it is 1 by root 3. You can do the calculations yourself, I guess. You are old enough for that. For 45 degree, it is 1. For 60 degree, it is root 3. And for 90 degree, it is undefined. Because 1 by 0 does not yield any real number. So these are the values which you have to remember by heart, because they will be extensively used in the chapter we are going to start next. We are going to learn about how to find the height of a tower, height of a man, height of various types of objects, cliffs, height of the flight of an aeroplane, so many different questions. So let's wait for the next session to unravel those questions, those mysteries of how to do it. One more interesting thing I would like to tell you, that initially when people were interested and curious about the position of the sun with respect to the earth, when they had no idea, when telescopes were a big dream for people, during that time trigonometry was the way by which people understood these type of things. So trigonometry dates back to those years and years ago, those historic centuries when people were extensively curious about the things going around. So understanding this chapter and learning this chapter is a very important part of our knowing things. So I hope this session was fruitful to you. You have learned a lot of new things, and I guess your neurons are working once again quite well. So we are going to finish it off now, and we are going to meet very soon with the next chapter. Till then, keep studying, keep rocking. Bye bye, everyone.